Hi students, good evening. Welcome to this video session. My name is Samuel Dominic Chupu Emeka, aka Sam Dom for Peace. In this video session, we shall discuss the study guide to your Module 3 homework assignment. Please, before you continue with this video, it is recommended that you know the basics. So you get on my website, you read the notes of the topics involved and view the videos as well, so to have a good understanding. As usual, in this video we shall use the calculator on my website and also Statcrunch. So we're gonna use both of them here. Statcrunch is not gonna do everything. My calculator probably wouldn't do everything either. So we're gonna use both of them, so you know how to use both of them. So I'm gonna get on my website. I will open up another browser. This is the first question. It is asking about critical values. So I'm gonna get on the mobile friendly site. As it's pulling up, let's look at the first question. It says compute the critical value Z subscript alpha over 2 that corresponds to 88% level of confidence. So let's get on my website, Samuel Chupu Emeka AppSpot, and the first link here. Click on mathematics and click on statistics, and then the resources here. And this is Inferential Statistics Calculator. Inferential Statistics Calculator. You click on it. So with this calculator, I have also listed the terms, the symbols and meanings. Alpha is your level of significance or significance level. And then the critical Z they are asking of is a critical Z value separating an area of alpha over 2 in the right tail. So I'm just gonna go here, critical values, click on it, and the confidence level is 88%. So here, when you're given the confidence level, this is what you use. So I'll put 88 and I'll click here and select percent. You make sure you select percent and then click calculate. So the critical value is 1.5548. They want us to round to 2 decimal places, so that's gonna be 1.55. So 1.55, and you can check answer or you press the enter key, it doesn't matter. Okay, later you can look at this, the instructor tip. Question 2, determine the point estimate of the population proportion, the margin of error for the following confidence interval, and the number of individuals in the sample with the specified characteristic, and that is X, for the sample size provided. So they gave us the lower bound of the confidence interval and the upper bound. We also call that a confidence limit, lower confidence limit and upper confidence limit. So this is population proportion. So when you get on this calculator, you can click on estimating population proportion. So here they gave us the lower bound, which is also known as the lower confidence limit. The upper bound is also known as the upper confidence limit. And then the sample size. So you look for the one that they gave you and they need to find, and that is this one right here. So the lower is 0.093, upper is 0.337, and the sample size is 1000. So I come here, 0.093, 0.337, and sample size is 1000. Make sure it is correct, verify it again, and you click calculate. So they want us to find a point estimate first. Round to the nearest 1000 as needed. The point estimate is the sample proportion. The sample proportion is the best point estimate of the population proportion. It is in the notes. Estimating population proportion. So nearest 1000 means 3 decimal places. So this will be 0.215. You put 0.215. Then the margin of error is 0.122. You put 0.122. Then X, the number of individuals in the sample with the specified characteristic. X, that is X if you look at these symbols here. X here. And that gives us 216. Okay, let's look at it again. Number of individuals in the sample with the specified characteristic. We put 216 and it says no. Just try 217. Okay, try 217. Okay, you try 215. Try 215. Okay, so what the individuals they round to the nearest integer, which when I wrote the JavaScript code for this calculator, I had to round to the nearest integer, but for some reason, if it says no, just round either up or low. It's just rounding errors. Okay, so if it says no, just round up. If it says no, round down, and that is it. I don't mind removing the rounding, and then you can round it yourself. I don't mind, but don't worry about it. It's gonna be correct, or you can round up or round down to one integer. Okay, you can read this later on. Question 3. Construct a confidence interval of the population proportion at the given level of confidence. So they gave us the this is 90% confidence, X is 860, and N is 1200. This question can be done by Statcrunch as well as my calculator. So let's use my calculator and do it, and then we can use Statcrunch. This one can be done by Statcrunch. So this is estimating population proportion. They gave us XN and then CL, confidence level. So look for given XN and CL. Okay, and they want us to find the confidence interval. Okay, so we're gonna kind of use this here. We'll use this right here. So confidence level is 90%. So we're gonna put 90, and here select percent. X, the number of individuals is 860. Sample size is 1200, and press the enter key. So it's asking us for the upper bound of the confidence interval, and this is the confidence interval here, the 90% confidence interval. The upper bound is 0.093, 0.738. This is also known as the upper confidence limit. Okay, so 0.738. We put that here, 0.738. Then lower bound is 0.695 is the lower bound. Okay. Question 4. Now let's go ahead and try this with Statcrunch. I'll show you how to do this with Statcrunch. So I'm gonna put similar question to change the question. I'm gonna come here, question help, get Statcrunch. And you go to let's restore this. Okay, you go to stats, and you're looking for proportion stats. Okay, estimating population proportion, and this is still one sample. What we are doing in this model is one sample. Later in other models, we are gonna do 2 samples. So this is one sample, and this is with summary. One sample with summary. X is the number of successes, and that is X60. Number of observations is the sample size, and that is 1200. Then you want to come here and click on this button here, confidence interval. And this is 90% confidence, so put 0.90. And leave it as standard word method. Under the method, leave it as standard word. And just click compute. And the upper bound in this case is 0.738. So you put 0.738. And the lower bound, which is the lower confidence limit, is 0.695. Okay, 0.695. Actually, that was the same question we just did. Yeah, the same question. Okay, question 4. A poll of 1,027 adults in a certain country found that 55% identify themselves as the followers of some religion. The margin of error was 5 percentage points with 99% confidence. Which of the following represents a reasonable interpretation of the survey results? If you can go on my website and read the notes on interpreting confidence levels. Under the notes section in statistics, you can do that. I gave several examples interpreting confidence levels. In this one, we are 99% confident. Okay, that here we can find the lower bound and the upper bound. Remember, the lower bound or lower confidence limit, the upper bound or the upper confidence limit. So the confidence level is just that, it indicates the degree of confidence or the level of confidence that the confidence interval actually contains the true value of the population proportion. If you're doing estimating population proportion, which is what this question is about. So to get the lower bound, we can take the sample proportion, which is here, is 55%. Proportion could be in percent or fraction or decimal. In this case, although generally is in percent. So the lower bound is going to be 55% minus 5 percentage points minus the margin of error. And that gives you 50%. And the upper bound will be 55% plus 5%, the margin of error. And that is 60%. So we are 99% confident that the true value of the population actually lie between 50% and 60%. So if you read the options, you can say that is looks like B. There is 99% confidence that the proportion of adults in a certain country who identify themselves as the followers of some religion is between 50% and 60%. And that is B. Okay? Question 5. In a trial of 191 patients who received 10 milligram doses of a drug daily, 42 reported headache as a side effect. Use this information to complete parts A through D below. A. Obtain a point estimate for the population proportion of patients who received 10 milligram doses of a drug daily and reported headache as a side effect. So the point estimate is the sample proportion. The sample proportion is the best point estimate for the population proportion, and that is x divided by n. In this case, our x is 42, our n is 191. So you can just do 42 divided by 191. Okay, you can do that. You can also use my calculator here. We are given x and n, and we're asked to find p hat. P hat is the sample proportion. So we are given x and n, and we're asked to find p hat. You can actually use this. I know they didn't tell us level of confidence, right? They did not. But that's fine. We can use this. X is 42, n is 191. So let's leave it as 90%. That's fine. It doesn't matter because we want to find p hat. P hat is just x divided by n. Okay, it is in the notes on my website, the formulas there. So you just do 42 here. X is 42 and n is 191, and just press calculate. So the sample proportion is 0.22. Sample proportion is 0.22. They say round to 2 decimal places. Okay. Then they said, B, verify that the requirements for constructing a confidence interval about P are satisfied. So these are the requirements here. I put it here. When you multiply n times p hat times q hat, it should be greater than or equal to 10. It should be at least 10. There are some other requirements also. There are other requirements as well. It should be independent. So another requirements as well. You can read that up. So there are about 4 requirements. I put 3 here. There are about 5 requirements actually, and I put 3 here. Okay, there's also 2 more. The sample size should be less than 5. They should be less than 5% the population size. Okay, that's another requirement. Okay, so with this question, let's verify that are the requirements satisfied. So we have the sample proportion as 0.22. Q hat is 1 minus 0.22. Okay, which will give us 0.78. Right, 0.78. So let's multiply that, see whether it gives us more than 10. N is sample size is 191. N is 191. So 191 times 0.22 times 0.78. So I'm gonna just pull up calculator here. Uh, 191 times 0.22 times 0.78, and that gives us more than 10. So yes, the requirements are satisfied. We hope that the other requirements are also satisfied. Independent is one of them. Each trial be independent. The sample size should be less than 5% of the population. Those are other requirements. But yes, it's satisfied. Okay. Construct a 90% confidence. Oh, and we got 90% here. Okay. So great. We just come over here. The 90% confidence. This is 0.171 as the lower bound. Lower bound is 0.171 and the upper bound is 0.269. Yeah, thank God we just got the exact question they asked. Okay, this is you can also, let's see here. Oh, we have another one here. Interpret the confidence interval. So we are 90% confident that the interval, if you look at this, this is the confidence interval here. And the 0.171 to 0.269. Interpret the confidence interval. Which statement below best interprets the interval? So we are 90% confident that the interval contains P. Okay? That the interval contains the true value of P. That is what it means. Before we go to question 6, let me kind of show you guys. We can do this with Statcrunch. Okay, we can do it with Statcrunch. Let me just go ahead and show you with Statcrunch. So, Statcrunch, and as usual, you go to you will go to Stat, Proportion Stats, one sample with summary. X is 10. X is not 10. I'm sorry. X is I'm gonna adjust this and bring this here. X is 42. Sample size is 191, and we want to construct 90%. So 0.90. Leave the method as standard word. Okay, and then compute. And that is the same answer we got here, 0.171, 0.269. Okay. Question 6. A researcher wishes to estimate the proportion of adults who have high-speed internet access. What size sample should be obtained if she wishes the estimate to be within 0.01 with 95% confidence? If A, she uses a previous estimate of 0.54, B, she does not use any prior estimates. Okay, this question is gonna be done with my calculator. I don't think Statcrunch does this. Now, we are gonna come here, and this is it's proportion of adults, so it's still proportion, and we're looking for n. We're looking for sample size. So estimating population proportion, and we want to find n. To find sample size n, here to find n, here also to find n, So let's look at what they gave us. They gave us the confidence level, and they gave us margin of error. Within, anytime you see within, it means the margin of error. Okay, if they say the question is within 3 percentage points, within means it could be below or above. Okay, so within means margin of error. So they gave us the margin of error, and they gave us the confidence level. And here they said uses a previous estimate of 0.54. So in this question A, they gave us the sample proportion. So let's go ahead. The one we're going to use is this one here. We're going to use this one. We're not interested in Q hat. No, we are only interested in the sample size. So this is 95% confidence. Okay. And the margin of error is 0.01 within. So I'm going to put 0.01 here. And I will not select percent. I will select points. I will select decimal. Okay, because this is not percent. If it does not say percent, please put decimal. Please. If it does not say percent. Even if they say within 3. Even if they say within 3. If they don't say 3%, use 3 and put decimal. Please. Then the sample proportion here is 0.54. So sample proportion is 0.54 and is in decimal because they didn't say percent. If they don't say percent, don't use percent. Just use decimal. And just press calculate. So sample size is 9543. 9543. Okay? And then if she doesn't use any prior estimates, so in this case, no sample proportion. So we're going to come and use this one here. So this is still 95% confidence level. Margin of error 0.01 and put decimal. Calculate. And the sample size here is 9604. 9604. Okay? Then it says, oh, this is another question. I thought there was another question to that. Okay. Question 7. Katrina wants to estimate the proportion of adults who read at least 10 books last year. Who read? Katrina wants to estimate the proportion of adults who read at least 10 books last year. To do so, she obtains a simple random sample of 100 adults and constructs a 95% confidence interval. Matthew also wants to estimate the proportion of adults who read at least 10 books last year. He obtains a simple random sample of 400 adults and constructs a 99% confidence interval. Assuming both Katrina and Matthew obtain the same point estimate, whose estimate will have the smaller margin of error? Justify your answer. So if you want a smaller margin of error means higher accuracy, higher width, higher confidence interval width, which in turn is higher accuracy. Then you have to get a large sample size. Excuse me. You have to get a large sample size. Okay, the larger the sample size, the better. So, if you look at this, the one that will have the smaller margin of error will be the one that has the larger sample size and the one that has the greater confidence level. You see somebody saying he's 99% confident, and somebody saying that she is 95% confident. So who has more accuracy? The person that is 99% confident, right? And that means smaller margin of error. So it's Matthew. Matthew's estimate will have smaller margin of error because the larger sample size more than compensates for the higher level of confidence. So that is it here. Okay. Question 8, you can look at this later on. T-value. Determine the t-value in each of the cases. Critical t. So we are gonna do this with my calculator and then with Statcrunch. Okay, I will do it, and I'll do it completely different questions so that you can know it well. When they said the t-value such that the area in the right tail is 0.05 with 13 degrees of freedom. So this, when they say something like this means alpha. Okay, alpha to the right, okay. Alpha over 2 in the right tail. So in the right tail is alpha over 2. That's what it means, the level of significance or the significance level. So you just come here, go to critical values, and we're going to look for critical T. We have 4 calculators for it. Critical T. We are here, the area, this means level of significance is 0.05. And because they say right tail is one-tailed, this test is one-tailed. If they say left tail and right tail, then it's two-tailed. But for this model, we are doing one tail. For this model, subsequent models, we're gonna do two-tailed test. So this right tail, so this means significance level, the 0.05. Usually when they give you decimal, and this is like 5% level of significance, which is 0.05. So you know that this level of significance. I'm going to put 0.05 here, and I'm going to put this critical T. I will select decimal. And this is 13 degrees of freedom. 13. And this test is one-tailed test. Is one-tailed. Calculate. So the critical T is 1.7709. So to 3 decimal places will be 1.771. Okay. The next one, find the T value such that the area in the right tail is 0.01 with 17 degrees of freedom. So this will be 0.01. I'll just change it here. 17 degrees of freedom. Calculate. And the critical T here is 2.567. 2.567. Okay. C, find the T value such that the area left of the T tail. Okay, this one is now left tail, not right tail, but this is to the left. It's still one-tailed. Okay, it's 0.15 with 23 degrees of freedom. Hint, use symmetry. So the left tail, you know, you're gonna have a negative. You're gonna have a negative value. You can't have negative area though. You're just having the negative value that corresponds to the area in that left tail. So let's go ahead and find it for right tail, and we just put a negative value here. So I'm going to put here 0.15, 23 degrees of freedom. 0.15, 23 degrees of freedom. And I'll just put negative 1.060. Okay, 1.060. Because it's left tail, the value, the T value is negative 1.060. And here it says find the critical T value that corresponds to 96% confidence. Assume 24 degrees of freedom. So in this case now they gave us confidence level. So I will come here, and I'm not going to use this because this is significance level. I use confidence level, and they say 96%. Select percent. Assume 24 degrees of freedom. 24. And the test as usual is one-tailed. Okay. So we come here and calculate. The critical T will be 2.172. 2.172. to 3 decimal places. 2.172. Okay? Now, let's do it with Statcrunch. Let's do this with Statcrunch. I'm going to put similar question. So I'm going to come here. I will get Statcrunch. Let's kind of adjust this. Okay. And the first one is right tail 0.10, 21 degrees of freedom. I come to start, I click calculators, and I get T. I get T here. Degrees of freedom is 21. And here, you don't put this here, please. This is the actual value. Okay, this is the actual T value. The area is what they gave you here. This area, you have to put it here. Area is 0.10. 0.10. And this is less than or equal to, so this is left tail. You want this to the right tail because that is what they asked, right tail. Okay. So area to the right tail, you see that this is now 1 point. Let's move this here. I need this so you can see it. Okay, hope you see it now. This will now be I want to adjust this to so you can see it side by side to kind of make sense to you. Okay, so this will be there you go. This will now be 1.3 the value 1.323. 1.323. Okay, then the same question, but now they changed it here. Degrees of freedom is 10. They're asking the same concept. And the area here, or the probability, is 0.005. Okay. And this is still right tail, area in the right tail. So you click on it. This is 3.169. Okay. Then the next question here, the C part is left tail. So what we are going to do is 18 degrees of freedom. Change it 18 degrees of freedom. And the area is 0.025. So but they want us left tail. So left tail. Okay. So this will be negative 2.101. 3 decimal places. Now, for confidence level, Statcrunch doesn't have confidence level immediately, but what you could do is 60% confidence and this is critical T value, so it's in the right tail. Usually when you say have critical T values, always in the right tail. Okay, so for one tail test anyway, always in the right tail. So 60% confidence means 1 minus 60% is 40%. 40% divided by 2, that's 20%. And 20% is 0.2. 0.2. Right tail. So we could have 0.2 right tail and 11 degrees of freedom. Yeah, that's just what you need to do for if they give you this confidence. You find the level of significance. And this will give us 0.876. Okay? And that's it. All right. Next question. Determine the point estimate of the population mean. Determine the point estimate of the population mean and margin of error for the confidence interval. So they gave us the lower bound and upper bound. You do this one with my calculator. you scroll down here to estimating population mean. And here they gave you the lower bound and upper bound, which is lower confidence limit and upper confidence limit. And they want you to find the point estimate. The point estimate will be, the point estimate of the population mean is the sample mean, and that is X bar. So we're going to come here, 22 lower bound, 28 upper bound. So just put here 22, press the tab key, 28, press enter. So the sample mean is the best point estimate of the population mean. And that sample mean is 25. So come here, you put 25. And the margin of error is 3. Come here, put 3. And that's it. Question 10. We're getting there, right? In a survey, 1,200 adults in a certain country were asked how many hours they worked in the previous week. Based on the results, a 95% confidence interval for mean number of hours worked was, the lower bound was 39.8 and the upper bound was 44.6. Which of the following represents a reasonable interpretation of the result? For those that are not reasonable, explain the flaw. A. There is 95% chance the mean number of hours worked by adults in this country in the previous week was between 39.8 hours and 44.6 hours. Okay, like we said, whenever you say 95% confidence interval, you're 95% confident that the mean number hours between 39.8 hours and 44.6 hours actually contains the population mean of the adults in the certain country that are of the adults in the certain country. Okay, I was looking to see whether there was anything more to it. So that is what it means. So when you say 95% chance, no, it's flawed. Okay, and this 95% chance, the mean number of hours worked, so it's flawed. It's making it, the interpretation implies that the population mean varies rather than the interval. That is why this is flawed. Okay, it's not a good interpretation of that. And when you say 95% chance, the mean number of hours worked by adults, that means it implies that population mean varies rather than that interval. Yeah, we don't say it that way. Next one. We are 95% confident that the mean number of hours worked by adults in this country in the previous week was between 39.8 and 44.6 hours. Okay, based on the previous week. This was actually what I was looking for. Yeah, based on the previous week. Yes, this is correct. That's right. Yeah, you're 95% confident that mean number of hours worked by adults in that country in that previous week is between 39.8 hours and 44.6 hours. Next one. 95% of adults in this country worked between 39.8 hours and 44.6 hours last week. No, this is incorrect. It's flawed because it makes it, the interpretation does not make it clear that 95% is the probability that the mean is within the interval. This interpretation makes an implication about the individuals rather than the mean. Okay? Because it says the 95% of the adults. So it's not making anything about the mean. Okay, so this is flawed. That's why it's making an implication about the adults rather than the population mean. So that's why it's flawed. Okay, next one. We are 95% confident that the mean number of hours worked by adults in a particular area of this country in the previous week was between 39.8 hours and 44.6 hours. Okay, they have changed the word in here. they've changed the word in here. They told us here in the question how many hours they worked in the previous week. They didn't say what area. You see that? Here they said mean number of, we are 95% confident, which is on a good footing, that the mean number of hours worked by adults in a particular area of this country. They didn't, that is not what the question said. Okay, so no, it's flawed. And it says here, the interpretation should be about the mean number of hours worked by adults in the whole country, not about adults in a particular area. Yes, that is why it's flawed. Okay. Question 11. A nutritionist wants to determine how much time nationally people spend eating and drinking. Wow. I wonder how many will be praying. People spend eating and drinking. Suppose for a random sample of 976 people, age 15 or older, the mean amount of time spent eating or drinking per day is 1.89 hours with a standard deviation of 0.58 hour. Complete parts A through D below. A histogram of time spent eating and drinking each day is skewed right. Use this result to explain why a large sample size is needed to construct a confidence interval for the mean time spent eating and drinking each day. We look at this here. C and D doesn't really give us any. The distribution of sample mean will never be normal. Distribution of sample mean will always be normal. It doesn't really tell us anything that we need to explain why a large sample size is needed to construct confidence interval. We are looking at what the sample should be. So we're looking at A and B. Okay. A, since the distribution of time spent eating and drinking each day is normally distributed. No. They told us here that it's skewed right. Okay. So they won't tell us in the question that it's skewed right. Assume a histogram is skewed right, and then they tell us it's normally distributed. So the answer should be B. Since the distribution of time spent eating and drinking each day is not normally distributed, which means it's skewed right in this regarding this particular question, then the sample must be large so that the distribution of the sample mean will be approximately normal. Because they asked us to explain why a large sample size is needed. That is what we need. Sample. Okay. B, in 2010, there were over 200 million people nationally age 15 or older. Explain why this, along with the fact that the data were obtained using a random sample, satisfies the requirements for constructing a confidence interval. Well, they told us to explain why it satisfies that requirement. So the requirement is already satisfied, right? So of course, if it's for one of the requirements is that the sample size should be less than 5% of the population. If you take 5% of 200 million, I'm sure 976 is less than 5% of that population. If we take 5% is 0.05 times 200 million. 200. 1, 2, 3, 4, 5, 6. That gives us 10 million. Of course, 976 is less than that. So yes, sample size is less than 5% of the population. Then C, determine and interpret a 99% confidence interval for the mean amount of time Americans age 15 or older spend eating and drinking each day. So let's do this with Statcrunch. I'm going to open up Statcrunch. Let me restore this. I'm going to come here, Statcrunch, and try to adjust this. Okay. We want to construct a 99% confidence interval for the mean amount of time. So when they, in this case, this is a estimating population mean. If they gave us the sample, they gave us the mean, and they gave us the standard deviation. This is the sample mean, 1.89, and then this is the sample standard deviation. So if they give you sample standard deviation, you use T stats. If they give you population standard deviation, you use Z stats. So we're going to come here. I'm going to go to stats. I'm going to go to T stats, because they gave us sample standard deviation. And this is one sample with summary. So the sample mean is 1.89. The sample standard deviation is 0.58. And the sample size is 976. Then we want to check this. We want to click this radio button here to confidence interval. And this is they want us to construct 99% confidence interval, confidence level. Okay, 99% confidence interval for the population mean. So we put 0.99. Okay, and we just click compute. You don't really need this, so you just click compute. And we see here, let's I want to move this here. Okay, there you go. So let's go ahead. We are 99% confident, okay, that the amount of time spent eating or drinking per day for any individual, okay, no, that is not the correct thing. 99% confident that the mean amount of time, okay, yeah, this is not, the B part is not the correct interpretation. We're 99% confident that this interval actually contains the mean amount of time spent by America, not just for the sample, but for the population mean, okay, spent by Americans aged 15 or older, spent by Americans aged 15 or older, the time they spend eating and drinking. So this is the mean amount of time we now put here. They want us to round to 3 decimal places as needed. I have explained as needed before. So this is 1.842, the lower limit, lower confidence limit, and then upper confidence limit is 1.938. 1.938, okay? And that's it here. Then the next question, could the interval be used to estimate the mean amount of time a 9-year-old spends eating and drinking each day? Okay, the question says people aged 15 or older, so we can't use that for 9-year-olds. We cannot, no. So A and C, okay, A and C. Now let's look at A. No, the interval is about people aged 15 or older. The mean amount of time spent eating or drinking per day excuse me, for 9-year-olds may differ. C, no, the interval is about individual time. No, it's not about individual time, no. So, this is interval is about people age 15 or older. The mean amount of time spent eating or drinking per day for 9-year-olds may differ. So A is the answer. Okay. Question 12. Based on interviews with 97 SARS patients. SARS is what? You know what SARS is? Severe acute respiratory syndrome. Researchers found that the mean incubation period was 4.7 days, with a standard deviation of 14.7 days. So they gave us the sample size is 97 patients. The sample mean is 4.7 and sample standard deviation is 14.7. So we are going to use t-stats also. So let me just go ahead and close this here. We're going to use t-stats. Based on this information, construct 95% confidence interval for the mean incubation period of the SARS virus. Then interpret the interval. So I'm going to go to start, t-stats, one sample with summary. The sample mean here is 4.7. The sample standard deviation is 14.7. And the sample size is 97 patients. Click on this radio button and is 90, how many percent? 95% confidence interval. So we just leave that, okay? And then compute. And scroll down a little bit here. So the lower bound here is round to 2 decimal places as needed. Lower bound is 1.74. Okay? 1.74. And upper bound is 7.66. 7.66. As you can see. Interpret the interval. We are 95% confident, or there is 95% confidence that the mean incubation period lies between the lower and upper bounds of the interval. Yes, that is the correct thing. Lies between that, yeah. So that's C. Okay, you can look at this later on. Question 13. The following data represent the asking price of a simple random sample of homes for sale. Construct a 99% confidence interval with and without the outlier included. Comment on the effect the outlier has on the confidence interval. Okay, so let's go ahead and do this with Statcrunch. Here, let me just close this Statcrunch. So if you look at this question here, they gave us this data here. So we don't need to come and start typing all this data. You know, we don't need to start typing it. Just come right here at this tip, click to copy the table, just click on it, and then click on open in Statcrunch. So open this in Statcrunch, and let's go ahead and construct 99% confidence interval. If you want, you can leave this as variable 1. If you're working in industry, you want to put asking price. You want to name the variable. Please, when you name variable, don't put space. Please, you see there are no space. There are no spaces between a variable 2. Between VAR and 2, there's no space. So it's important, just, you know, don't put space. And this is just asking price. You know, you can use variable 1, VAR 1, it doesn't matter. But I just wanted to do extra thing, you know. So you come over, here they gave us the data, okay. and they did not give us the population standard deviation. If they gave us population standard deviation, you use Z stats. If they give you sample standard deviation, you use T stats. Here, they didn't give us anything. They just gave us a sample data. That means they didn't give us anything for the population. So we're going to use T stats. So click on stats, start, click on T stats, one sample, and this is no longer with summary. This is with data because they gave us the data. So you select one sample with data. And here for the columns, click on asking price to select column. And they want us 99% confidence interval. So click here on this radio button and put 0.99. Okay. We still have the outlier. Of course, you will know what the outlier is. The outlier, if you look at this data, outlier seems to be 459,900. That's a lot of money. I don't have that at all. So, so you come here. If you want, let's kind of plot this, and you kind of see it. So I'm gonna select box plot with min marker. Okay, and I click compute. Let's go ahead first and answer this. So the lower limit is round to the nearest integers needed. Lower limit is 154,368. Okay, if you round to the nearest integer, 154,368. So 154,368, and then the upper bound is 309,399. 309,399. Okay, 309,399. Okay. Now, if you want to see this, let's look at this. Because let's see, if you move here, so you see the box plot. You see this outlier here. You see how it's so far. For the 459,900. That's the outlier. When you construct a box plot, see, this is the outlier here. Okay, let's go ahead and close this. Next question. Construct a 99% confidence interval with the outlier removed. So let's go ahead and delete this outlier, 459,900. Let's remove it. And let's construct another confidence interval. So T starts one sample with data. Select asking price, come over here, put 0.99. And let's go ahead and box plot with min marker to kind of see it. Compute. So here the lower bound is 162,894. 162,894. And the upper bound is 259,415. 259,415. 259,415. 259,415. Right? Okay. Just making sure. Enter. Check answer. Okay. Now if you look at this also, you'll see that there's the outlier. There's no longer outlier. See that? Okay. The next question. Comment on the effect the outlier has on the confidence interval. Let's look at this and see which one of them has the margin of error, the least margin of error. Because you know, the smaller the margin of error, the higher the accuracy. Okay, the greater the width of the confidence interval, and then the higher the accuracy. So If you want, we can use my calculator here. This is a population mean. Okay, population mean, and they gave us the confidence limits. So estimating population mean. Oh, there you go. They gave us the confidence limits. First one is 154,368. So 154,368. And this one is 309,399. 309,399. So here the margin of error is 77515.5. Okay, 77,515.5. That is the thing with the outlier. You can write it down somewhere. Okay, with the outlier, 77515.5. Now, without the outlier, let's see the margin of error. Here, this is 162,894. 162,894. And the upper bound is 259,415. 259,415. Enter. So here, the margin of error is 48260.5. So you see, without the outlier, this has a smaller margin of error. Without the outlier, so the outlier actually increased the margin of error. It increased the width. Okay, and it reduced the accuracy. That's the effect of the outlier. Yeah, the effect of the outlier, it caused the width of the confidence interval to increase. Okay, thereby making the margin of error to also increase because the confidence limits with the outlier is bigger than the confidence limits without the outlier. The margin of error with the outlier is bigger than the margin of error without the outlier. Excuse me. So it caused the width of the confidence to increase. Okay. It made the margin of error to be bigger. It caused the width to increase. Yeah, but without the outlier, you have a smaller margin of error and hence a higher accuracy. You can read this later on. Question 14, last but not the least. A doctor wants to estimate the mean HDL cholesterol. I've forgotten what HDL means. Okay. Something high, something, right? Cholesterol. Of all 20 to 29-year-old females, how many subjects are needed to estimate the mean HDL cholesterol within 4 points? Within means margin of error is 4 points. Okay. They're asking us for how many subjects, so they are asking us for the sample size. How many subjects are needed to estimate the mean HDL cholesterol within 4 points with 99% confidence, assuming the sample standard deviation is 10.8 based on earlier studies? Suppose the doctor would be content with 95% confidence. How does the decrease in confidence affect the sample size required? Okay, this one, my calculator can do it. I don't think Statcrunch can do it. I don't know. I don't think so. So, you come to estimating population mean here. And we want to find sample size. They want us to find n, sample size. Okay. They gave us the margin of error, 4 points. They gave us the confidence level, 99% confidence level. Although they told us that the doctor would also be content with 95% confidence. But the first question is 99% confidence level. So come here, look to find n. Want to find n. To find n. Okay, I know that this is population standard deviation. I know. We can also use this for, they gave us sample standard deviation. And I know the sigma here is population standard deviation. But this calculator will work for it, okay? So S is 10.8. We put 10.8 here. Confidence level, the first one is 99%. 99%. Margin of error is 4 points. They didn't say 4 percentage points. They didn't say 4 percentage. So put 4 and put it in decimal, not percent, please. Calculate. So here, with 99% confidence, the sample size required will be 49 subjects. Okay? Then 95% confidence will require, just change this to 95. Calculate. Will be 29. Smaller sample size, 29. How does the decrease in confidence affect the sample size required? Decreasing the confidence, as you can see, decreases the sample size needed. So the answer is B. Okay? All right. Thank you so much for listening to this video presentation. You can just click save. And you have a great day.